In this video, we'll take a look at polyatomic ions. Polyatomic ions are a cation or an anion that has more than one atom in it. So these are typically covalently bonded molecules that just happen to have an overall charge associated with the molecule. Here's an example of them, and you'll have this polyatomic ion chart on exams and quizzes. And so we've got our chemical formula here and the actual name of it. The naming, we will not expect you to memorize the naming conventions for naming things that have oxygens in them, like perchlorate, chlorate, chlorite, hypochlorite. But I would like you to be able to recognize that you have a polyatomic ion in your compound and be able to then determine its charge. So if you look at these, we could see something like OH is hydroxide. If it was paired with a metal like potassium, then and if I was looking at this, I would say, okay, well, I have this metal, and then I have nonmetals that follow. So I think this is an ionic compound, but it has more than one covalent molecule, and so really, or more than one nonmetal. And so these must go together and be covalently bonded. If I didn't have this chart, I could still figure out its charge. I would separate these and say, well, I know my cation has a plus charge because potassium is in the first group, so it's +1. That means if I have just one of these hydroxide molecules, that it has to balance out this +1 charge. So it must be -1. So here is another example where we have a +1 and -1, where we're bringing together sodium and nitrate or nitrite. They have sodium has a +1 charge, and this NO2 species has a -1 charge. So +1 plus -1 equals 0. If I combine these in a 1-to-1 ratio, I'll have an overall 0 charge. When I bring together barium and sulfate, it's the same thing. I've got a +2 plus -2. This comes out to an overall 0 charge. So I could combine these in a 1-to-1 ratio. And now if I was using just the crisscross rule, I would look at barium and sulfate, and I might crisscross these and get barium 2, SO4, 2. But I can simplify this, since these subscripts are the same, to barium sulfate. This does highlight something important, though, and it's the use of parentheses and subscripts. When you have a polyatomic ion, it might already have a subscript involved in its overall chemical formula. And so to show that you have multiple of these polyatomic ions, it's important to put them in parentheses followed by the subscript 2. So that way you know you have 2 of these sulfate units. A great example of this is actually hydroxide. So we looked at potassium hydroxide before, but let's look at barium hydroxide. So barium's +2 and hydroxide is -1. If we wanted to combine these so they had an overall 0 charge, I would need to have 2 of my hydroxide units. So that way, and you can get that also from the crisscross rule, that this 2 would have to be a subscript of 2 over here. If I wrote this as barium OH subscript 2, what this reads as is barium bonded to water, because this 2 will just be distributed to the hydrogen when it's placed after it. If instead I use parentheses, OH2, this 2 is distributed to everything in the parentheses. This is saying that I have 2 hydroxide units.